My worst programming error, because everybody loves worsts. This was back in the late 80s, working. My boss's company was a small programming house. It was basically me and a couple other freelancers at the time. And we had the chance to develop for the Atari 7800. And prior to that, he had been mostly doing like Commodore 64 and Apple and stuff like that had memory. And this was the first machine that he had for his stuff that was a ROM cartridge. And I had said, hey, back at RPI, I'd had a class, we made ROM cartridges and things like that. And why don't we just do this? So he jumped in, and it was pretty amazing. He studied about how to make a circuit board and how to make a RAM controller and, make a static RAM and have controller logic chips that were programmable to interface it and hook it up to an Atari 7800 so it would emulate the cartridge for it. And I wrote the software that ran on the Atari 7800 to be the development system interface. So we would program on a PC, compile stuff on the PC, and then download it to the 7800. And what we had was really clever. It was based on what he had done on like the Commodore 64 and stuff like that, which was an interrupt-based development logic. So whenever the development system, the controlling computer, wanted to do something, it would generate an interrupt, and the system, in this case the 7800, would run code. So I wrote this code for the 7800, and we came up with like, we'll need this command, and all of this wonderful stuff. And this was my first, professional, real, serious programming project going on. And one thing that it just didn't occur to me at the time, the way you write a 6502 interrupt is you push the A, the X, and the Y register. That's the three registers. That's all you've got to worry about. So you push them to the stack, you run your interrupt, you pull them at the end. And bear in mind that these systems, there's so little going on. You're moving the bad guys doing whatever stuff, and then you store the A register into something called wait sync, which would basically freeze the processor and wait until the next vertical blank of the screen. So 60 times a second, it'd wait, then run your code, and then wait for the next thing. So most of the time, the processor is doing nothing. It's just waiting between generating whatever you want to do for the next frame. So this interrupt would just, pop in whenever the development system wanted to do something and issue a command. So I was like, hey, I'm going to save time. This will be brilliant. I'll only use the A and X registers. So instead of doing 5 instructions to start the interrupt and 5 instructions to come back from an interrupt, it'll only be 3. Just save the A register, save the X register. And off we went. And the development system worked, and it was really amazing because we could just download code to the 7800, run it. We could check how memory locations were changing, make changes on the fly. Very cool stuff. And every once in a while, it would crash. And, this was the first time he had done something like this, so there's all kinds of things to check. Did he make an error in the logic gate programming for it? Did he make an error in designing the circuit board? This was all stuff he learned on his own. I have no idea how pre-internet he achieved this. It was absolutely amazing. All the stuff he figured out. So all kinds of errors. We thought maybe it was RF interference, because normally on those machines there's like a little metal thing that goes over the processor and this RF warning about TV interference and stuff. So we were doing things. We were putting aluminum foil over it in different configurations and all of this stuff. And it's like some days the development system would just work and everything was fine. And some days it would just crash, and it was really annoying, and we couldn't figure out. And this went on for a long time, and it was, really disruptive because you're going along and everything's working great, and then it just crashes. Now, I hope you see where I'm going with this. At some point, we added some feature to the development system that used the A, X, and Y registers during an interrupt, and they had never been saved in the, beginning and never restored at the end. And again, like I said, most of the time, the processor's doing nothing. It's waiting for the screen to get to the next start of the vertical blank. And so most of the time, you can interrupt the processor, destroy all the registers, and it doesn't affect anything. Once in a while, if you're in the middle of actually running code and your registers change, boom, it just blows up really bad. And this, we just kept trying things, and hey, maybe it's the wires. And like I said, we were playing with aluminum foil construction and trying to attach and reattach things differently and stuff. And then one day he looked at my code and it was like, oh, duh. And wow, retrospect is, wow, he didn't just fire me for being such a problem programmer. Because, of course, you never only save 2 registers on a 6502 interrupt. What are you saving? It's like nothing of nothing of nothing. So anyway, that was it. That was the intermittent error. Now, the reason that this is sort of follow-up to my last video about Godot is this is that type of insidious problem where you have something. The reason he never looked at my code is, why would you look at how I wrote that? That was such a basic, obvious thing. I mean, that's textbook how to write an interrupt on a 6502. He would never have to look at it. And, even if I had commented, oh, I'm only using the A and X registers, like who reads that comment later on to go, oh, I'm adding in a new feature that's going to do this and it uses the Y register. Insidious errors take forever to find, and they're really, really just frustrating. And my previous video about Godot was one of the things is you can hide some things in the settings on a node. You can have an animation that runs code that does something. All of these things can be set in a sublevel of a sublevel of a sublevel. And if you don't look there, you can't find them. So you can be like, I don't know why this is happening, but it's a setting you set. And, you have to actually go down through the tree, check each node, check what settings and stuff you did in there. And that's what I was kind of showing in my last video. That can be so hard to track down, and it can be so frustrating. And the thing is, with Godot, working forwards, generating stuff, and you're adding nodes, and just like, oh, here, I'll just add this and make it do this, and then I'll add this and make it do that, and I'll keep adding things. Moving forwards, it's very clean, very fast, and you make such great progress. But the problem I have with it is just, how do you mentally backtrack? And the way we used to backtrack in the old days was, when you just run out of stuff, you look at the program listing. And if you had a printer, you print out the program listing and you start at the top and you work your way down, because that's how the CPU is going to execute the code. And then someone would have looked at my interrupt like my boss did and was like, that's not how you start an interrupt. Of course it's not working. Anyway, that's a more roundabout way of getting to what my thing was with the last video. Anyway, that's my worst programming error. It was so frustrating. It took so long to find. Please like the video for the YouTube algorithm.